Previously, you have identified angles that are formed by two intersecting lines, and they're called vertical angles or linear pairs. Now we're going to take the instance when you have three intersecting lines, and you will identify the kind of angles that are formed when two lines are intersected by a third line, and that third line is called a transversal. So here are the situations. If you have two lines, they may or they may not intersect. So that's one. Two lines may or may not intersect. Second, if they don't intersect, then they are skew or parallel. I think you all sort of understand what parallel means. Parallel lines never intersect. They go on forever and ever. They're going exactly in the same direction, and they will never intersect. Skew lines. Two lines are skew lines if they do not intersect and they are not coplanar. So let me draw a line in this plane. Okay, I'm going to call it T. So line T and line M lie in parallel planes. Planes A and B are parallel. So lines T and M lie in parallel planes and they will never intersect. Similarly, lines T and lines L also lie in parallel planes. They will never intersect. So these lines are called skew lines. T and M are skew. T and L are also skew. And this is what we are talking about here. Non-intersecting lines in different planes are skew. Two lines are skew lines if they do not intersect and are not coplanar. So two conditions. They do not intersect and they're not coplanar. Note that lines N and M are not coplanar, but they do intersect, so they are not skew. Next, let's look at the example of two lines that are being intersected by a third line. The intersecting line is always called the transversal. So let's just first of all identify the angles that are formed and the name that we give to them. Okay, so let's choose the color red. If you notice, angle 1 and angle 2 both sit on the same side of the transversal. Let me just label this transversal. That's the intersecting line. So angles 1 and 2 sit above the two lines and they are on the same side of the transversal. So these are in correspondingly same positions. They are called corresponding angles. So this is an example of corresponding angles. In fact, there are other pairs here that are corresponding. So 3 corresponds to 4 because they're on the same side of the transversal and they're both below the two lines. How about 5 and 6. These are also corresponding. They're on the left hand side of the transversal and they're both above the two lines. Finally, 7, 8. These are all corresponding. So let's label the pairs here. 1, 2, 3, 4, 5, 6, 7, 8. These are corresponding angles. Next, let's just look at this highlighted section, and it is loosely a Z formed by the two lines and the transversal. Angles on alternate sides of the transversal but within the two lines are called alternate interior angles. So let's call this 9, 10. There is another pair of alternate interior angles. This is like a backward Z. And these are also alternate interior. So 9, 10, 11, 12 are alternate interior angles. Now that we have taken care of the interior angles, let's talk about alternate exterior angles. Well, just as before, alternate means they are on either side of the transversal, but now they're going to be in the exterior or outside the two lines. They're not going to be within the two lines, but they're going to be above or below. So let's start with the number 1 again. 1 and 2. These are on alternate sides and they're both outside. Note that I've been careful in not trying to indicate that the angles are congruent by making sure that the number of arcs is different on each angle. So we've got corresponding angles, alternate interior, alternate exterior, and finally we are going to talk about same side interior. And same side interior on the same side of the transversal, and they're within the line. So 1, 2. 1, 2, same side interior. 3, 4, same side interior. Let's just make one more connection. So 5, 6. These are same side, but they are same side exterior. 5, 6 and 7, 8. Another word that can be used instead of same side is consecutive. Consecutive means same side, just same side. So same side interior or same side exterior. Okay, let's now talk about parallel and perpendicular lines. If you have two lines in the same plane, they're either going to be parallel or they may intersect, and if they intersect, then they may intersect to form right angles, in which case they are perpendicular. So let's just draw these different cases. So you've got line, and another line. Now you cannot assume they are parallel unless you have these arrows on them, which now states that these two lines are parallel, and the way you show that is M is parallel to N. You may have intersecting lines. So these two lines are intersecting lines, but there's nothing here to indicate that they are intersecting at right angles. Let's look at another diagram here. Correctly, these are two rays that are perpendicular. So if I called it S and T, I would say S is perpendicular to T, and I am just going to make these into lines. So S is perpendicular to T. The parallel postulate states that if there is a line, so let's look at that. If there is a line and there is a point that is not on the line, then there is exactly one line that goes through the point is parallel to the given line. So this is what we're saying, that you can only draw one line that is parallel. So this is point P, which is not on line M, and through point P we can only draw one line that is parallel to line M. Similarly, the perpendicular, so I'm going to just loosely write parallel postulate, and the perpendicular postulate states that if I am given a line, so here's my line, and then I'm given another point that is not on the line, and we'll call this point T just to be different, then there is only one line through the point T which is perpendicular to the given line. Let's call that P, and that is the perpendicular postulate.